Okay guys, so we are going to be looking at multiplying and dividing rational expressions. The previous lesson we did was excluded values and simplifying or reducing them. Today we're multiplying and dividing them. I went ahead and wrote out the notes so the video would be a little bit shorter. You're not going to have to sit there and wait for me to write this all out. But to multiply rational expressions, factor like we did before, cancel like we did before, or cross cancel, which is almost the same thing. I'll show you that when it happens. Then just do top times top, bottom times bottom. When you multiply fractions, that's how it works. When it comes to dividing, you flip the second fraction and then follow the steps for multiplying. And it's going to be just, once we get good at multiplying, the dividing is going to be pretty simple. When it comes to excluded values, every problem when you work with rationals has some sort of consideration about excluded values. It's what we talked about before. But to keep this assignment simple and straightforward, we're just not going to worry about them right now. So don't let that enter your head. So here goes. Everything you see here, multiply, multiply, multiply. Every problem has that little dot there for multiply. Then you get down here and that switches to divide, divide, divide. 12 problems. I do the even, so you're looking at 6 problems here for assignment. Okay, so what do? Factor and then cancel. So anything in this expression, is there anything in this expression that can be factored? This numerator right here, 9n and the 27, you can actually do common factoring and factor out a 9. That's going to leave you with n plus 3. The rest cannot be factored. There's no way you can divide anything out or anything like that. So the only thing that factors is the numerator there. And then, so like I said in the notes up there, factor and then cancel. You can cancel this n plus 3 with that n plus 3 and they're gone. Now you might ask, can you cancel with this n plus 3? And you can't. Once it's canceled, it's gone. So if these are both gone, there's nothing left to cancel with that one. Remember, or maybe you don't remember, when things cancel, they actually leave ones behind. So this says 9 times 1 times 1. Well, that just works out to be 9. And then 1 times n plus 3 is n plus 3. And that should be the answer. That should be all there is to number 2 right there. Okay? So that was pretty simple. There wasn't a lot of factoring. Number 4, there kind of is a lot of factoring. So I'll take you through this. Here we go. All right, first, this numerator. From both of those terms, I see a 7 in common and an n. So I can do common factoring, factor out 7n. If I take 7n out of 7n squared, it's just going to leave n and a minus sign. If I take 7n out of 70n, that's going to leave 10. The denominator here is n minus 9. That will not factor. You can't really do anything with that. This 1 up here is just going to stay a 1, but this quadratic, I can do this kind of factoring. So I put down n and n. I need two numbers that'll multiply to 40 and add up to negative 14. Well, 10 times 4 is 40. Negative 10, negative 4 adds up to negative 14, so there it is. Now when it comes to canceling, there is nothing that'll cancel. You might say, well, here's an n, can you cancel those out? In order for, you have to cancel basically entire factors together. You can't just cancel out a part of a factor. This n minus 9, together is a factor. You can't just cancel a part of it out. So you would need another n minus 9 somewhere to cancel this whole thing out. So no, you can't cancel this n with that n. It doesn't work that way. There's nothing, on top here, on bottom here that match to cancel. There's nothing top here, bottom here that match to cancel. But we can do something called cross canceling. N minus 10, and then if we cross over this times sign, there's another n minus 10 there. You are allowed to do that. It totally works. Remember, when things cancel, they just leave ones. I don't usually write them in. I did up here, but generally it doesn't matter. On top, we've got 7n times 1, so top times top is 7n. Bottom times bottom, n minus 9 times n minus 4, we would write that like this. You'd have to put them both in parentheses. Oops, that 4 looks too much like a 9. And that should be our answer. Let me jump down to number 4 and see where to go. And yep, there it is. Now, you could FOIL this all together if you feel like you're just not doing enough homework and you really want to, have some fun on your spare time. Go ahead and FOIL those together. Otherwise, that's your answer. Okay, if you didn't get that, sometimes repetition is good. Let's look at number 6. So I'm rewriting this so that I can factor it. And honestly, this is the only thing that's going to factor. So I'm going to bring the rest down. And a squared minus 3a minus 40, a times a, what will multiply to 40 and add up to negative 3? Well, I think the trick here is 8 and 5. Negative 8 times positive 5 is 40. Negative 8 plus 5 is 3. Now, if you look at this a minus 8 here and the a minus 8 up there, those are going to cancel. A plus 5 cancels with a plus 5. We're left with a plus 6. There's nothing on the bottom. Technically, they are 1s. 1 times 1 is 1. But with fractions, if you have a 1 denominator, you can just disregard it and call that your answer. I guess I don't need the equal sign in there. I'll just circle it like that. Losing my voice, sorry. Number 6 then should be a plus 6. There it is. Okay, so the rules are, again, factor anything that'll factor, cancel or cross cancel, and then do top times top, bottom times bottom. 8 through 12, I'm sorry, 7 through 12, I'm doing 8, 10, and 12, are divide problems, but basically what you do is you just change it to times and flip the second fraction over. So here we have, so you're basically rewriting the original problem, and then we're going to do the steps we did before. Now, I see something here, and I'm about to break the rules that I laid down up above. I said factor and then cancel. Could I factor this? Yes, I could. I could factor out a 4r, and that'd give me 7r minus 5. But the reason that you factor is that really when you factor, it shows you things that are going to cancel out. But do you see how this and that are already exactly the same? 28r squared minus 20r. They're totally the same. So what you can do is you can just treat them as though they are factors. They're just big factors. And cancel them out. And then you're going to be left with r plus 3 on top and 4 on bottom. So on that one, we could save some of the work of factoring because there's already identical numerator and denominators. The whole thing's cancel anyway. So number 8 should be r plus 3 over 4. R plus 3 over 4 right there. Let's look at number 10. So we need to flip the second fraction over and change it to times. And then factor everything that we can. All right, 7n and 7n are monomials. They're not going to factor. The top one we can factor out a 3, and we'll be left with 2n minus 5. The bottom one we can factor out a 3n, and we'll be left with 2n minus 5. And it looks like a lot of stuff is going to cancel. So 7n and 7n, the 2n and the 2n, I'm sorry, 2n minus 5, 2n minus 5. The 3 cancels with the 3, and what we're left with is just an n on the bottom. You can't leave the top blank, so remember when you cancel, it leaves behind little ones. So 1 times 1 times 1 is 1. And that should be our answer for number 10. 1 over n. There it is. So you have 1 on the bottom of a fraction, you don't need it. If you have 1 on the top of the fraction, you have to have it there. Number 12. So flip the second one over. And then if you can combine steps, maybe you can flip it and factor it at the same time and save a little work. That's fine. Of course, I'm showing all the steps. So there it is. Change it to times and flip the second one over. Always just the second one. And then factor. So this top is a trinomial. I can do the FOIL thing. And what'll multiply to 72? All I can think of is 9 times 8. Oh yeah, 9 plus 8 is 17. So 9 and 8, and in this problem they're going to have to both be negative. Two negatives multiply to a positive, but they add up to a negative. So there's that. The denominator right here, I see a 9 in both terms, so I can factor out a 9, and I will have n plus 9. So part of me is wondering, wow, did I make a mistake? I mean, this n minus 8 cancels with that n minus 8. Can I cancel this with that? Not if they're not completely identical. No, you can't. So on top we have 1 times n minus 9. That's just n minus 9. On the bottom, 9 times n plus 9. And I'm thinking that's the answer. And there it is right there. So they didn't put the parentheses on top, and I understand why, because there's really nothing there for them to be multiplied by, so you don't really need them. You multiplied by a 1 right here, so it didn't really do anything. All right, I'm kind of mumbling. Sorry. So the rules you follow for multiplying: factor everything. I should put a comma here. Factor, comma, cancel or cross cancel. Then do top times top, bottom times bottom. For divide, flip the second fraction over and then just treat it like a multiply problem. Do everything that you learned how to do up here. Every problem does technically have excluded values, but you don't need to worry about them. If this were a type of assignment where you did have to worry about them, you'd put that answer here. I know you probably don't want to know this. Comma, n does not equal negative 3 because a negative 3 plus 3 would equal 0. That's okay. Okay, why did I even do that? Don't worry about it. That's your answer. You're done. Okay, so do the odds. Do them like I did the evens. I tried to make the problems very similar. They're not like same, but they kind of work out in similar ways. So use the notes to your benefit. Check your answers, of course. Show your work. Submit it, and then contact me if you have any questions. Other than that, hope you have a great day. Bye-bye.